Hello, this is Mrs. Ross, and this is 3.1 Analyzing Functions. This is the lesson. I'm going to go through this fairly quickly since we're going to do this in class, and you're welcome to pause it or what have you. So, increasing, decreasing, and constant functions. Our goal with this lesson is to look at graph characteristics, look at our graph, and find where a function is increasing, decreasing, or constant. So an increasing function, so as x increases, y increases. So we have, this is basically y1 is less than y2, okay? As x1 is less than x2. So we can see this is y1, this is y2, and y1 is less than y2, and x1 is less than x2, so this is an increasing function. Decreasing function, as x increases, y decreases. Another way to write it would be y1 is greater than y2 when x1 is less than x2. So example, x1 is less than x2, y1 is greater than y2. So this would be y2, y1. And lastly, a constant function, as x increases, y remains the same. And you can see that here. Increasing, decreasing, and constant functions example. Where is the function increasing? Where is it decreasing? Where is it constant? Okay, so we can separate this into, let me grab a different color. What about blue? So we'll do, we have this part, it increases to there and then decreases. So we have that it is increasing from -5 to -3. We have that it is constant from -3 to -1. It's increasing again from -1 to +1. And then it's decreasing from 1 to infinity, because this goes on forever in this direction. Okay, now we try. It says, where's the function increasing, decreasing, and etc. constant? So where'd I can't see it. Okay, so I'm going to draw my lines. I know it changes there, and then it changes there. So we have that it is increasing from -infinity, because that's here, to -1. Okay. It's decreasing from -1 to +1. And then it increases again from 1 to infinity. This function is never constant. Okay. All right, so identifying intercepts. So the x-intercept is the point of the graph where the function intersects or crosses the x-axis. The y-intercept is the point where the graph of the function intersects or crosses the y-axis. For example, here we have the x-intercept. Here, it crosses the x-axis here at -2, 0. It also has another x-intercept at 1, 0. We have a y-intercept at 0, -2. Now here's our fun fact. A function can have lots of x-intercepts, but it can only have one y-intercept. If it has more than one y-intercept, it's not a function because it doesn't pass the vertical line test. Okay? All right, here's our example. It says the graph of a piecewise function. Side note, don't worry about this word right now. We have a whole unit on this, and it's like 2 units from now. I don't know why they're using this now when we haven't learned what a piecewise function is. just chill about it, and we will keep on going. So it doesn't really affect what we're trying to do. Okay. So it says identify the following values. F of 1. So when x is 1, f of 1 is 2. So this is 1, 2. Okay. The x values for which f of x are, let me change, -3. So let's see. The x values for which f of x is negative. So f of x is -3 here, and it's -3 here. Okay, because we're looking at this is f of x or y, right? So the x values are -4 and 4. Okay. And then it says for which values is f of x or y greater than 0. So we're looking at like everything on this side of the, so it would be from 0, because it starts here, is less than x is less than or equal to 3. This is that. So it's between 0 and 3 that it's above the line. Okay. Let's do some more examples. Okay. Again, we're not going to worry about that. That's going to come later. F of 2. So let's see. F of 2. So when x is 2, y is 0. See, that's when x is equal to 2, y is equal to 0. Okay. The value, let me change colors. The x value for which f of x is equal to -2. So let's see. This is y. So -2 is going to be right here. So my x value is -2. Okay. The x values for which f of x is less than 1. Okay, let me get another color. Less than 1. So if I were going to draw a line, here's a line at 1. I know that from -3 to -1, it's less than 1. Right? All of this is less than 1. And then from 1 to 5. So we're just looking at below the 1 there. So I would have 2 intervals here. And then my other one is from 1 to 5. All right, application, speed of a vehicle. Okay, let me change colors. This is actually applicable in physics. So it says, when is the car decelerating? So we're looking for decreasing. When is it constant? How fast is it going at 5 minutes? And then what are the x-intercepts? What is the car doing? So let's do A. When is it decreasing? So if I know it's decreasing. Ooh, what happened there? Don't know. From 2 to 4 minutes, and then from 6 to 8 minutes. So 2 to 4 and 6 to 8. Okay. It is constant, has a constant speed. Keep in mind, this is speed versus time. Not position versus time, speed versus time. So our slope would actually be acceleration on this one. I'm going to try and erase whatever that happened there. Okay. Constant, so it's constant here, right here, from 4 to 6. Okay. C, it says, how fast is the car going at 5 minutes? So at 5 minutes, I go up to here, and it is going 30 miles per hour. Come up to here, read across here, okay. And then lastly, D, what are the x-intercepts? So we have an x-intercept here, and we have one here. So we have an x-intercept at 0, 0, and we have an x-intercept at 8, 0. And that's when the car is stopped. It is not going anywhere. Okay, let's do this activity. Use the graph to find the intervals in which the function is increasing, decreasing, and constant. Express your answers in interval notation, which is what I've been doing this whole lesson. So I'm going to cut this wherever it changes. So we have decreasing here, increasing, this is constant, decreasing, constant. So for decreasing, I have from -4 to -2, and from 3 to 4. Okay. For increasing, I have from -2 to 0. That's all I have for increasing. And then for constant, I've got 2 constant. I have from 0 to 3 and from 4 to infinity, because this goes on forever. Okay, I'm going to erase this and do 2. All right, so this is 2. I'm going to put this up here so you can fit it on your paper. And we're doing the same thing, increasing, decreasing, and constant. So I know that there's a change here. It looks to be increasing from here, constant, and then increasing here. So this is never decreasing. Okay, so we are increasing from, if I start here, this is negative infinity to -3, and then from 0 to infinity, because that goes on forever. And then it's constant from -3 to 0 right here. That is supposed to be a 3. That doesn't look anything like a 3. All right, I think this is it. Nope. Not so lucky. Okay. All right, given this graph, find the x-intercept, y-intercept, f of 3, blah. Okay, so x-intercept. So this one, every time it crosses the x-axis, we have an x-intercept. So my x-intercepts are -4, 0, -2, 0, and 2, 0. Let's get a different color. My y-intercepts, there should only be one if it's a function. Right there. So that's going to be 0, -2. So f of 3, when x is 3, on the function we get 1. Okay, so this is x is equal to 3, and y is equal to 1. And then last one here. It says x values for which, actually let me pick a different color. X values for which f of x is equal to 3. So let's see. So 3 is here, so we have here, and we have here. So that's at x equals -3 and x equals 4. Okay, I've got one more. I think I'm going to pause the video and do that on a separate video.